Welcome to Geology 2020, the Introduction to Petrology. This is Episode 2, Igneous Texture. Rock identification is based on texture and composition. In this video, we will look at the textures of igneous rocks. Texture is important because it gives some indication of the physical conditions obtained during the formation of the rocks. A magma with a given composition may form several distinct rock types depending upon the temperature, hydrostatic pressure, rate of cooling, and the presence of gases. There are three main factors involved in texture. They are the degree of crystallization, magnitude of the crystals, and the fabric. The degree of crystallization describes the amount of crystals within the rocks. A rock can be made up entirely of glass, entirely of crystals, or a given proportion of the two. The size of the crystal usually denotes cooling rates. Glassy rocks are cooled very rapidly, and larger crystals have more time to form. If a rock looks like a block of colored glass with no visible mineral crystals, it has a glassy texture. Superficially, a glassy texture suggests cooling that was so extremely fast that no crystals could form. However, the composition is also vitally important. The high silica concentrations found in felsic rocks causes a rock to form a glass much more readily than it would in low silica rich rocks such as basalt. Thus, the rate of cooling of a felsic and mafic lava flow could be the same, but the felsic flow would form a glass because it is packed with silica. The second factor is the magnitude of crystals. The crystals present may be very minute, small, or large, thus furnishing a fine-grained rock, less than 1 millimeter in diameter, medium-grained rock, where the grains are between 1 millimeter and 5 millimeters in size, or coarse-grained rocks, where the grains are greater than 5 millimeters. The third factor is fabric. This denotes the relative size of the crystals and their shape and arrangement. If the crystals are of the same order of magnitude, the rock is said to be even-grained. If the crystals are of different orders of magnitude, the fabric is said to be porphyritic. In this case, the larger crystals are called phenocrysts, and the matrix is called groundmass. The crystals themselves may be euhedral, subhedral, or anhedral, and if euhedral, they may be tabular, prismatic, or equant in habit. A euhedral crystal is bound by its crystal faces. Subhedral has part of a crystal present, where an anhedral has no crystal faces at all. The crystals may have more or less parallel arrangements, or they could interpenetrate each other and thus form what we call a graphic texture. In volcanic glasses, spherulitic aggregates of the feldsparts are often present. To describe texture, we want to look at the groundmass and determine the magnitude of the crystals. Fine-grained rocks are referred to as aphanitic. Coarse-grained rocks are referred to as phaneritic. In addition, we will look at the degree of crystallization and how much variation is in the crystal size. If the rock has phenocrysts, then we would call the texture porphyritic. You can have a porphyritic aphanitic rock, such as the one on the upper right, or a porphyritic phaneritic rock. In addition to texture, we often look at the rock's structure for additional information. These include the larger features in an igneous rock. Most rocks have massive structure, but in some, the rocks can be banded, columnar, or spheroidal. In volcanic rocks, we use other terms to describe texture. Vesicular denotes vesicles or gas pockets within a rock. As lava reaches the surface, gases come out of solution and expand. If the rock cools before the gases can escape, these bubbles are trapped in the rock. This is common in rocks such as basalt, pumice, and scoria. Later, if these voids are filled with minerals such as zeolites, calcite, chalcedony, quartz, etc., the structure is said to be amygdaloidal. Volcanic clastic or volcanic breccia describes the rock that is made up of smaller rock particles. These are found in rocks such as tuff. This rock is a volcanic clastic, and this one is more volcanic breccia. So let us test what we have learned so far. In this sample, what is the degree of crystallization? What is the magnitude of the crystals? What is the fabric? And does this have structure? Based on the texture and structure of an igneous rock, we can determine the mode of occurrence, or the environment in which the rock was formed. Igneous rock masses may be divided into three large groups: extrusive, injected, and subjacent or intrusive. Extrusive rocks are formed by cooling excuse me, of the magmas on or very near the Earth's surface. They are well-known lavas found around volcanoes. The term lava and volcanic rock should be restricted to extrusive rocks and should not be used as a synonym for igneous rocks. Extrusive rocks comprise of two general classes: fissure eruptions and central eruptions. The great basaltic lava fields of eastern Oregon and Idaho are examples of fissure eruptions. The lava has issued quietly through narrow fissures and probably were very fluid at the time of extrusion. Central eruptions are extrusions from a single vent. They comprise of volcanic cones, plugs, and surface flows. This would include volcanic ash and tuffs from your classic volcanoes like Mount St. Helens. Injected rocks form the smaller intrusions such as dikes, sills, and laccoliths. A dike is formed by the injection of a magma into a relatively narrow fissure not parallel to the bedding plane of a sedimentary rock. If the fissure is parallel, a sill is produced. The term laccolith is used for a dome-shaped intrusion which has a bowed or overlying strata. Subjacent rock bodies, also known as intrusive, comprise of batholiths and stocks. A batholith is a large rock mass of indeterminate shape and size exposed by erosion in mountainous regions. Smaller masses are called stocks. By now, you should be able to identify texture and the three components of texture, the structure, and the mode of occurrence. Now you can apply these terms to your igneous texture lab. Our next episode will be on the classification of igneous rocks. Thank you for watching.